Welcome to Homework Lib.
We have data from 2 samples and we want to know if there is a significant difference. Do we think there's a difference in the population means? Let's start with hypotheses. Now, if there is no difference, which should be the null hypothesis always has an equal sign, it represents no change, no difference, then the difference between the population means is expected to be 0, no difference. If there is a difference, the difference between the population means would not be 0. It would be something else. Positive if the mu1 is larger, negative if mu2 is larger. So those are the matching hypotheses here. Part B, we want the p-value. Okay, so to perform a hypothesis test, we start by assuming the null hypothesis is true. So we have these 2 populations, Publix and Trader Joe's, and they have the same population mean, we think. If I were to take every sample of a given size from one of these populations, take the means and put them out, I'd get something approximately normal, thanks to the central limit theorem. Same for the other population. The difference between 2 normal distributions is also normal. So if I were to take every possible sample from each, look at the differences in sample means, plot all of them out, I'd get this approximately normal distribution. So this is x bar 1 minus x bar 2, approximately normal. The mean is the same as the population means difference, so we think that's just 0. For the standard deviation, well, there's kind of the pooled standard deviation, which is sigma 1 squared over n1 plus sigma 2 squared over n2. This is the pooled standard error because it's the standard deviation of a sampling distribution. In this case, sigma is the same for each, it's just 12. So that's going to neaten up very nicely. Now we have some information. Sample size 1, 250. Sample mean 1, 86. Sample size 2, 300. Sample mean 2, 85. Now, I want to know where our difference in sample means, which here is 1, would fall on this curve. If it falls here, then sure, it's not 0. But this isn't unusual. It is plausible that this difference belongs to this curve, and that the null hypothesis might be true. But if our difference is way out here, I might say, well, if the null hypothesis is true, something this extreme is really unlikely. Therefore, I don't think the null hypothesis is true. The p-value is the probability of seeing such an extreme sample result. So the p-value is the probability of our outcome, or something more extreme, given the null hypothesis is true. If this p-value is really small, we found something that was really unlikely to happen, and it sheds doubt on the null hypothesis, and would lead us to reject it. Now, in this case, we have a two-tailed test. I care if the difference is very positive or very negative. We're interested in just a difference either way. So we have our difference of 1, x bar 1 minus x bar 2. We also look at minus 1, and we want both tails. A two-tailed p-value is twice the size of a one-tailed p-value. It's the difference between the probability of such a positive difference and the probability of such a difference generally. Now, let's get the pooled standard error, which I'll just put as SP, or pooled. So this is obviously going to simplify a lot. 12 squared over 250 plus 12 squared over 300 is 1.056. Does that square root nicely? No, it does not. So root 1.056. Okay. So we've got all the information we need. Now, this is a normal distribution, or approximately normal, so I just need something with the normal distribution built into it. I'm going to be using my TI-84 calculator with the normal CDF function. It has 4 inputs: lower bound, upper bound, mean, and standard deviation. I'm going to go from -1 to 1 with a mean of 0 and the pooled standard error that we see here. This is going to give me the area between -1 and 1 on this particular curve. Not quite what we want, but if I take it away from 1, I'll get the area of the tails. The total area under a probability curve is, after all, 1. So this gives me what I don't want. Let me put that in. And this is 0.6695, which leaves the tails adding up to 0.3305. Now, decimal places. How does that round? Let me check. So it's 0.669508. So it rounds to 0.330. Okay. So there is our p-value. That's a pretty high probability. We're saying that if there really is no difference in the population means, well, if you were to take 2 samples of these sizes, look for difference in sample means, 33% of the time you would see something as extreme as we saw here. Not surprising. And if we look at the level of significance, that's alpha, that's 5%. That means if we see something 5% or less likely, then we reject it. We didn't see that. Our p-value is greater than alpha. We did not see something unlikely enough. So we're not going to reject the null hypothesis because there is insufficient evidence to conclude that the population means are different, which is option 2. Which appears to have the greater customer satisfaction, if any. We can't really conclusively say. No comment. Sure, it might be Publix, we got a higher sample mean, but as we've just said, it's entirely plausible that population means equal. So I don't want to make any comment on which is better. And finally, a 95% confidence interval for the difference in population means. So this is an interval that centers on the difference in our sample means. That's our point estimate. And we add and subtract a margin of error, which is Z, the critical value, multiplied by the pooled standard error. 95% confidence means the critical value here is Z sub 0.025. I draw a curve to demonstrate this. Our interval is wide enough to contain the middle 95%, leaving 5% in the tails, so each tail is 2.5%. This is 1.960. You might have a table of those. If not, just use the inverse normal function. So we have 1 plus minus. So I've got the pooled standard error for 4, root 1.056. I'm going to multiply that by 1.96. Give me an error, 2.014. If I subtract that away from my point estimate, I get the lower bounds of my interval. It's 1.01. Add it on, I get the upper bound, 3.01. So looking at that, this is a kind of range of plausible values. 0 is in the interval, meaning no difference is plausible. So that matches up with the test we did before.